So today we're going to start working on chapter 1. Day 1 is all about multiplying, dividing, adding, and subtracting fractions. So everything that you see on the board should be right there on your handouts. If not, you might have grabbed the wrong one, so double check. All right, so first we're going to focus on multiplying and dividing fractions. Multiplying and dividing fractions is a little bit easier than adding and subtracting fractions, and here's why. You do not need common denominators to multiply fractions. Typically in your notes, if something has stars and bolds, that means it's important. So this is a pretty important idea. You might want to put even a bigger star or a smiley face or something like that on there just to show you this is important. This is a big one. Okay, you do not need common denominators to multiply and divide fractions. Here are the steps for multiplying fractions. So you can read along with what's on the board or you can check out your handout. The first thing you want to do is you want to change all mixed numbers to improper fractions. So mixed number, it's a big number, a whole number, and then a fraction. We just want a fraction. So when you go from mixed number to a fraction, it will be improper. It'll be top heavy. That's fine. We just have to get them all in that form first. The next thing we want to do is take out any common factors in the numerator and the denominator. You guys know the numerator's the top, the denominator, D down, denominator's the bottom. So if there is a common factor in either of the tops and either of the bottoms, one from the top, one from the bottom, you can simplify it first. Then you multiply across the top, you multiply the numerators. Then you're going to multiply the denominators, the bottoms. And in this class, we don't go back to mixed numbers, just leave it as an improper fraction. It makes it easier on all of us. So even if it starts out as mixed, just leave it improper. Any questions so far on multiplying fractions? All right, next we'll look into division. So dividing fractions is very, very, very similar to multiplying fractions. Same first step, change all mixed numbers to improper fractions. Here's where it gets a little different. You have to flip the fraction immediately following the division sign. So whatever is right after the division sign, that's the one that gets flipped. And then you follow the steps for multiplication. Any questions on division? All right, we can go right into our first example. So here's where your writing is going to pick up. Your notes just say example 1 and it has a blank. So you have to actually write this out and then we'll go through it together. So I'll give you a second. All right, so the first thing we want to do is exactly what you just said. We want to simplify anything that we can. So do you guys know a number that can go into any of those? Yes, ma'am.
2 and 4.
Yeah, the 4 and the 2, we can simplify these, okay? And again, you're looking for a number from the top and a number from the bottom. So the 4 is on top, the 2 is on the bottom. 2 is a factor of each of those. So I am going to cross those two numbers out, and I'm going to divide them both by their common factor. The common factor here is a 2. So 4 divided by 2 leaves me with a 2, and 2 divided by 2 leaves me with a 1. I usually put a 1 here. This PowerPoint doesn't have the 1 there, so when I click on the next step, that 1 will go away. But I usually put the 1. It just makes me feel good about the situation. Any questions so far? All right, the next step is to multiply across the top. I'll just add that 1 back in so you know what I'm doing. So I multiply 1 times 2. That's how we get a 2 on the top. On the bottom, I do 1 times 7. That's how we get a 7 on the bottom. What questions do you have? All right, so number 2, we have 7/8 divided by 21. Anyone know what we should do first?
Skip the first value, flip the second value, and then multiply.
Very good. So we want to first change it to multiplication, and we have to flip that second fraction. Now this one's kind of tricky because the second fraction was a whole number. Anytime you have a whole number and you're working with fractions, just put a 1 on the bottom. So this is like 7 over 8, or 7 divided by 8, divided by 21 over 1. So we flip the second one. Now it's 1 over 21, and it's a multiplication problem. Anyone know what the next step would look like? Yes?
You simplified, you can simplify it 7 and 21.
The 7 and the 21. Good. What goes into 7 and 21?
7.
7. Good. So I'm going to cross those both out. And divide them both by 7. 7 divided by 7 is 1. This is where I snuck that 1 in on the last one. And then 21 divided by 7 is 3. Now we just multiply, just like on the last one. So what's 1 times 1? 1. So we'll have a 1 in the top. What's 8 times 3?
24.
So we'll have a 24 in the bottom. There's our answer. What questions do you have? Number 3 is a doozy. Numbers are getting bigger. And I think I might have failed to mention this. In Algebra 1 Advanced, we don't use calculators in Chapter 1. So I'm hoping you guys are going to be able to get this without the calculator. So we might have to write out some multiplication off to the side.
I forgot. You can do it multiple times if there's multiple factors.
Yes, so sometimes if you don't pick the biggest factor that they have in common, you have to simplify it a couple times. That's fine.
No, I mean like if, like say 64 and 56 have a common factor. but
Oh, and then
21
15.
and
Yep.
50.
Uh-huh. Yeah. All right, so I think you're one step ahead of us. What's the first step?
You would write out the fraction, of course, but then you flip 21, 56, and then make a multiplication problem.
There you go. Good. So we changed the division to multiply, and then we flip that second one. So instead of 56 over 21, now it's 21 over 56. Now you can start taking out common factors. Does anyone know where we can start? Yes.
7 and 64 and 56 have a multiple of 7. Wait, what up? I multiplied them.
Yeah, I was going to say 7 times 9 is 63. So I think you're just one number off on that one. Anyone else know a common factor of those two? Yep.
8.
8. Yep. Very good. So we can divide both of them by 8. I'll get there in a second. They did it the other way. There you go. So we can divide these two by 8. So 64 divided by 8 gives us an 8. 56 divided by 8 gives us a 7. Did I say 4? I think I said it wrong. I'm doing too much in my head. And then over here, these are both divisible by 3. So 15 divided by 3 is 5. And then 21 divided by 3 is 7. All right, any other ideas on what we can do next? Or we can just see what comes up. Now you have a 7 in the top and a 7 in the bottom. Even though they're in the same fraction, that's fine. Any top, any bottom during this sort of process, you can simplify. So 7 over 7 would just become 1 over 1. All right, so to finish that off, we would multiply across the top. 8 times the 1 that was left in the back gives us 8. And 5 times the 1 that was left in the bottom gives us a 5. Now, there are multiple ways to do this. Some students would do 64 times 21 and then 15 times 56 and then simplify those two very large numbers. If you're about that, go for it. I am not going to judge. All I need to know is that you're showing me the work, you're doing the work on your own without a calculator, and that you're arriving at the correct answer as an improper fraction. Any questions? All right, let's keep on going. So we have 3.5 times 4 2/3. This is one of those problems where we first want to change it to an improper fraction. The way we do that, and you might want to make yourself a note if you're unsure of this, you multiply these two and then you add this one. So we do 2 times 3, that's 6, plus 1 is 7, and then you keep the denominator the same. So that would turn into 7 halves. Same thing back here, we do 3 times 4, that's 12, and 12 plus 2 is 14. And then you have a 3 as the denominator. All right, now you can divide out any common factors. Yeah, the 2 and the 14, they're both even numbers, so they're both divisible by 2. When you divide 2 by 2, you get a 1 down there. Again, it's that invisible 1. And then up top, 14 divided by 2 gives us a 7. And then when we multiply across the top, we have 7 times 7. Across the bottom, we have 1 times 3. So that gives us 49 over 3. Questions? Thank you. You can wait till notes are over. It usually says send now if that's like urgent, so you can give it a couple minutes. All right, we good on this one? Mm-hmm. Here is number 5. This is our last multiplying and dividing example, and then we'll go to the adding and subtracting. And then I'm hoping to give you a little time in class to work on some homework. All right, so the first thing we want to do, we have a mixed number back here. We want to rewrite that as an improper fraction. So the way I do that is I do the 10 times 1, that's 10, plus 7. That's how I get the 17 over 10. And then what's next? Skip, flip, and multiply. I love it. So now I keep this 7/8 the same, change the division symbol to multiply, flip the second one. And then same old process, I think you guys are getting it by now. Look for common factors. The 8 and the 10 are both even numbers. Even numbers are always divisible by 2. So when I divide 10 by 2, I get a 5. When I divide 8 by 2, I get a 4. And then we multiply across the top. 7 times 5 is 35. Multiply across the bottom. 4 times 17 is 68. If you didn't know that bottom one, you need to go off to the side and write it out old school, okay? 4 times 7 is 28, so you write that, carry the 2. 4 times 1 is 4 plus the 2 up top. Everyone remembering that? been a long summer. We good? All right, let's take it to the back of your handout. This is all about adding and subtracting fractions. Here is where that common denominator stuff happens. This is tricky, okay? You must have common denominators to add or subtract fractions. Common denominator is kind of the fancy way to say the same number on the bottom. So we need the same number on the bottom of both fractions before we can add or subtract the top numbers, okay, the numerators. Here are the steps, and these are the same steps in your notes, so you can follow along on your handout or check it out on the board. If the denominators are different, the first thing you want to do is reduce each fraction. Sometimes you reduce, they reduce to have the same denominator, you're good to go, okay? So you always just want to check to make sure everything is reduced first. Then you want to find the LCD. LCD stands for least common denominator. So the smallest number that you could make both of the bottoms. And we do that through multiplication. So what's the smallest number that they can both multiply into? Then we want to change the numerator of any fraction if you change the fraction's denominator as well. So let's say you have to multiply the denominator by 2. You also have to multiply the numerator by 2. You multiply top and bottom by the same number. Add or subtract the numerators. Keep the denominators the same. So that's another difference between multiplying and dividing, adding and subtracting. Multiplying and dividing, the numerators and denominators change. Here you only change the tops, okay? So the denominators stay the same. Once you find that common denominator, that's it. You add or subtract the numerators. Unless, of course, you're reducing. Reducing is the only way that you would change those denominators. And we reduce in the same way we just were reducing. You find a factor that goes into both top and bottom. Questions? And then once again, don't forget to leave your answers as improper fractions. So what do you notice about example 1? Yes? The denominators are already the same, so you can go right for it. 8 minus 4 gives us 4, right? And then the 10, that common denominator does not change, okay? If you're getting 0 for all your denominators, you're subtracting way too much, all right? Leave those the same. You subtract the tops, leave the bottoms the same. Unless, of course, like in this case, we have to reduce. So how are we going to reduce this? Yes, sir?
Divide both numbers by 2.
Divide both numbers by 2. They're both even, so that's always kind of the easiest way to do it. So 4 divided by 2 is going to give us a 2. 10 divided by 2 is going to give us a 5, and then that's our final answer, 2/5. Questions? All right, here's the next one. Number 2 in our adding and subtracting section. So this is where it gets a little tricky because our denominators are not the same. So we want to find the least common denominator for fractions that have a 7 and a 6 on the bottom. Yep.
So can we simplify the number to 6 before we solve the problem?
You can. Yep. So his idea was to change the 2/6 to 1/3 and do it that way. Did anyone else have that same idea? That's actually how our notes told us to do it, so I'm gonna go rogue for a minute here. I'm gonna do it my own way. So this would be a 1, this would be a 3. Doing it this way, what would the least common denominator be?
21.
21. Good. Now, how would you turn a 7 into a 21? Times 3. So I'm going to multiply the bottom by 3. I'm going to multiply the top by 3. It'd be 9 over 21. Good. All right, what do I multiply 3 by to make it a 21? 7. So I'm going to multiply the top by a 7 as well. So that would be 7 over 21. Then we add the top. What's 9 plus 7?
16.
16. And of course the bottom stays 21. So this is one way to do it. This is not the original way that the notes had it completed. But I do prefer this way. So very good. I'll show you the other way in a second, though. If you already wrote this way down, you don't have to do it twice. If you started going with the 42, though, and you just went for it, that's fine. You should end up with the same answer. I'll show you both ways to do it. That's why algebra is so fun, because there's so many ways to do the same problem. All right, everybody good to go on this method? All right, here's the other way. You could notice that 7 and 6 both go into 42. So the least common denominator is going to be 42. We multiply that one by a 6. Multiply the second one by a 7, top and bottom. So 3 times 6 gave us the 18 over 42. 2 times 7 gave us 14 over 42. Add them. They're both even numbers. Boom. Are you guys impressed? Same answer. And we didn't even touch numbers as big as 32 and 42. So that's why I said I prefer the way we did it, but there's another way if you like. You guys have questions? Is this all coming back to you? Okay, good. If you guys look in your algebra books, which remember you can keep those in your locker, we don't need those. This isn't actually a section in the algebra book. This is just the most common things that students make mistakes on is the fractions. So if you're thinking like, oh, I learned this in 3rd grade, you did, and it's just a very easy fix if we spend one day talking about it, so that's why we're doing that today. All right, here's number 3. Especially when we don't let you use calculators, it's kind of important to review the fractions, so hopefully I'm not boring anyone too much. All right, so right now we have mixed numbers. Let's go ahead and make those improper. So we would do 6 times 7, which is 42, and then you add the 1 on top. That's how we got 43 over 6. Minus, in the back we have 6 times 4. That's 24. Plus the 5 is 29. Next step is to check for common denominators. We lucked out here because we have them. So you can go ahead and subtract. And I'm coming up with 14 over 6. How do we feel about this answer? Yes?
You need to reduce.
You need to reduce. Those are both even numbers. Divide top and bottom by 2, you get 7/3. And again, do not go make it a mixed number. We need to all keep our answers in the same form. This is the accepted way to answer algebra problems, is with improper fractions. I don't even like mixed numbers. All right, anyone needing extra time? All right, here's your next one. I am going to have you guys do these on your own. So go ahead and just knock it out. All right, so I gave you some time there to check with a partner. Now you guys can check to see if it matches what I ended up with. I'm hoping if enough people around you got the same answer, that means that you're all doing it right, or you're either all doing it the exact same way wrong. I will show you though, I saw a lot of people get to this point, the 9/4 and the 11/3, and then they paused. And they just sort of looked around, okay? If you're to the point where you're pausing and looking around and wondering when the answer's going to fall into your lap, that's where you go back in your notes and read through those steps, okay? You are only on, I think, step 1. This is step 1 of the problem, okay? So keep reading down that list in your notes to see what to do next. You would be finding the least common denominator, which is 12. You have to multiply this one by 3/3. That's how we ended up here. Multiply this guy by 4/4. That's how we ended up here. Add the tops. No common factors, so we're good. How are we feeling about fractions? All right, we do have one more example. Here's number 5. Okay, I am not even going to let you start this one on your own because I don't want anyone to start multiplying 28 and 33. Did anyone feel like they wanted to do that? Yeah, don't do it. It sometimes this breaks my heart to watch you guys do all that extra work for no reason. What's maybe a better approach? Yes.
Simplify 28 and 22.
Oh, we can't do it that way.
Why not?
Because we have a plus sign in the middle. What could we simplify?
22 and 33.
Yes. When there is a multiplication symbol in the middle, that's when you can crisscross. When it's a plus sign, we can't do that. But we can do the 22 over the 33. 11 goes into both of them. And then check these two out as well. Yeah. So you can go ahead and divide top and bottom here by 4. You end up with 1/7. Back here, you end up with 2/3. All right, give it from here, give it a shot. Sorry, I just had to give you that heads up before anyone got too crazy. All right, what's the magic number? 21. If you're just sitting there staring at your paper not knowing what to do next, think about what 7 and 3 can both go into, and it's 21. So your goal is to change both denominators to a 21. So to get that common denominator of 21, you have to multiply the first fraction by 3/3. To get that 21 in the back, you have to multiply by 7/7. And we end up with 17/21. Raise your hand if you got that all on your own. Woo! Look at that. I think you guys are ready to end the notes for today. Don't put them away yet, though. We got one more slide. We end every set of notes with a quick summary. There is not a place on your notes for this. These are just sentences I want you to write below our examples. So you should have a little space down there. Yep, anywhere you can fit it on these notes. And you don't have to write out the questions. Well, actually, let's just do this one together since it's our first one. So I want 3 quick sentences. Today, what did we do today? It was a review, so I'm not even going to say we learned. I'm going to say we reviewed. Yes?
We reviewed on how to divide, multiply, add, and subtract fractions.
Good. We reviewed dividing, multiplying, adding, and subtracting. Fractions. Good. And don't forget, at the end of every chapter, I grade your notes. And I will be looking for the word summary followed by 3 sentences. All right? And before I print the packets next chapter, I'll try to remember to build this part in, but I forgot. All right. The next sentence you should start with, I'm still confused, or I'm still wondering about. You finish it off.
What if we're not confused about it?
Then you can, still confused about nothing. But you can't be confused about nothing every single day. I'm still confused about the least common denominator. Tricks me sometimes. Or I'm still confused about changing mixed numbers to improper fractions. Or I'm still confused about simplifying fractions at the end. Write yourself a little note if something is still bothering you. And then you can either come ask me privately after notes. You can begin class tomorrow with this question. You can ask this question to your study hall teacher or your math tutor or your LS teacher, whoever, okay? This is just a nice place for you to be like, later I need to make sure I figure this out. All right? And then the last sentence, I want you to write a sample test question for yourself. Anyone have one? Yes.
7/16 plus 9 1/3.
All right, good. Now, I'm not going to solve this, or I'm not going to actually evaluate this now. I'm going to leave it just like that. And the night before the test, I'm going to go back and I'm going to answer all the questions I've written for myself throughout the chapter. And that's going to help me prepare for my test. Okay? Now, we didn't write a sample question for multiplying and dividing, so if you want to do that too, you can. That's just additional help for you in the future. Okay? There's just made it up. All right, here comes your homework. Any lingering questions? Anything from this section of your summary that you want to know about? Now, when we start class tomorrow, we're going to review the day 1 notes first using highlighters. So if you don't have your highlighters yet, try to get them tonight, or you can borrow them from a buddy, or I have a big basket up front. But the highlighters are also going to be involved in the note-taking process very shortly. If you already highlighted, that's fine. We'll get you going even a little better tomorrow. Questions?